Hi, it's Marco from Donut Lab. You are watching our battery proof series called I Donut Believe. In this series, we demonstrate the capabilities of Donut battery, which is the world's first solid-state battery used in production vehicles. In the last episode, we did a deep dive into the battery pack inside the new Verge TS Pro. That pack is a great example of what Donut battery makes possible. A very simple pack architecture, very few components, air cooling, and still performance levels and charge speeds that have never been possible before. Today, we are looking at something smaller. Not the full motorcycle pack this time, but a demonstrator battery pack built to answer a question we keep hearing from our customers, which is how far can you really push this? Because once people see the Verge pack, it makes you wonder, could this technology also be used in existing vehicles? Could you actually design a compact, swappable battery that replaces the batteries already on the road and bring the benefits of Donut technology into products that were never originally designed for it? Imagine upgrading, for example, existing scooters with double the range or more while having faster charging, better safety, and longer lifetime. And from the battery pack design perspective, simpler cooling, fewer parts, and so forth, which directly affects the cost of the battery. So we took up the challenge. We built this demonstrator to show what Donut battery technology could do in a smaller, swappable pack design with just air cooling. And the important point is this: it's not just theory. These kinds of solutions can be built already today with our technology. And many of our partners are actually working on very interesting products as we speak. Now, of course, every vehicle and every customer case is different, but the core point is that Donut battery gives OEMs a completely new design space. You can really start thinking about batteries in a much simpler way. Less complexity, less thermal management, and less wasted structure, while providing at the same time more usable energy, faster charging, longer range, and more performance from the same physical space. That is why we are now working with OEMs in multiple industries, helping them to bring to market new products that were very difficult, or in some cases even impossible, with traditional battery technology. And this demonstrator is a small example of that. So let's go and have a look at it.
To demonstrate benefits of Donut batteries in small swappable battery pack use cases, we selected a market-leading scooter battery to be our benchmark to compare against. This pack has a nominal voltage of 50 volts and energy capacity of around 1 kWh, which is very typical for scooters and other small swappable batteries. Currently, these kind of batteries can be charged slowly at an apartment or garage, but they would greatly benefit from faster charging speeds when used in a battery swapping service. And of course, increased safety of the Donut battery is the biggest benefit in both of these use cases. Our demonstrator pack is around 35% smaller in volume than the benchmark, while also having about 35% more energy capacity. This means it has more than twice the volumetric energy density of the benchmark pack, and it's also a couple of kilos lighter than the benchmark. All of this makes it easier to carry around, but also greatly improves the driving range of the vehicle. As usual with Donut batteries, the pack design is as simple as it gets. So we have cells arranged side by side with thin aluminum plates in between them, transferring heat into two slightly thicker aluminum plates on the outside enclosure. These plates would be connected to a cooling system in the swapping station when the battery is being charged. Charging speed and the amount of cooling would of course be determined by the use case of the station, basically how many batteries are needed per hour. But to simulate use inside a station with relatively small cooling capacity, we attached two heat sinks on both sides of the pack and added two small fans to force air into them. When we look at the charging test, it starts with the battery completely drained, and it gets to 50% state of charge in 3.5 minutes and 80% state of charge in 6.5 minutes, while hitting a peak charge rate of over 10 C. Cell temperature inside the pack reaches 82 degrees Celsius at its highest, which is near our recommended maximum for the pack, but is still very much in the comfort zone.
Thanks, Ville. Even with this simple demonstrator pack, you can already start to see how much donut battery can really change everyday life. Take last mile delivery, for example. Today, these vehicles often depend on small swappable battery packs, and riders use the same bike every day, swap batteries, charge them indoors, and try to get as much range and uptime as possible from very limited space for the battery. Now, in last mile delivery, range and charge speed directly affect how much business you can get done in a single day. Now, imagine replacing the existing pack with a donut battery made in the same format. You could charge the same bike up to 10 times faster. Or if an OEM decided not just to match the existing battery capacity, but to use the full space available for the pack, it could be possible to double or even triple the daily delivery range in the same size. And because this is solid state and extremely safe, you could bring the pack inside your home for the first time without having the small thought in the back of your mind, is this thing actually safe to keep here? And that is what makes this so exciting. We are redefining what's possible by changing batteries in the products people use every day. Delivery bikes, scooters, tools, robots, small vehicles, and products where battery size, charging time, and safety matters a lot. And this demonstrator is just one small example of what donut technology can do. Thank you so much for watching, and see you next time.